Hello, I'm Dr. Yung. Today I'm going to talk about a review on vision-based object grasping automation with QR code. The talk will cover introductions, object grasping systems, monocular vision-based system, and our proposed system, monocular vision-based object grasping system with QR markers, and we'll conclude the talk. Robots has been adopted in industrial for decades. Yeah? Basically, the purpose of adopting the robotics is basically to maximize productions and minimize dependency on labors. Yeah? So, in the industrial environments, most of the items or products are consistent. Yeah? So, the application of robots or robotics will have no major problems. Yeah? By extending the application of robots to daily life, for example, e-grocery or the online shoppings that require a pickup process, yeah, this will become more complex, yeah, to the industrial environments. Yeah, however, this is necessary, especially during this COVID pandemics, yeah, COVID-19 pandemics. We require social distancing. However, due to the surge of online shopping, yeah, overwhelming of pickup process is required. Yeah, companies and grocery store hire more people for pickup process. Yeah, this incur more contact of labels here, which we try to avoid during this COVID pandemics. Yeah. So if we can implement robots in doing the pickup process, so we can actually uh, reduce the social contacts of the labels. Okay, so in this review, we focus on a few things here. So first is the object grasping system, which is the automation of picking process. And vision-based system, yeah, we here embark on monocular vision, yeah, uh, because of the multiple vision and the binocular visions are much more complex in terms of installation and calibration. Yeah? And because of the mono vision, also we require markers, yeah, for good identifications and so on. Yeah? So in here we use the QR markers. So for object grasping system, basically is to pick up the items, yeah, and deliver to another location. Yeah. So this process requires first to detect the targets, yeah, to detect this target and determine the grasping position and orientation. And this information, yeah, will send for execution and to move the robot's arm and grip the objects. So the type of vision-based grasping automations can be categorized in few configurations. Yeah? The first one is the eye in hand, where we mount cameras on the robots, yeah? Near to the grippers. Yeah? And second one is called eye to hand, yeah? Where the camera are stationary on the platform, yeah? Um, capturing the image of the grippers and objects. Yeah? And some researchers also combine these two configurations using both the station camera and the camera that mounted on the robot arms. Yeah? So each of these systems having the benefits. Yeah? For example, the eye in hands. Yeah? You have more exact tracking position because the camera will provide the actual position of the robot's arm towards the object. Yeah? And free mobility means the camera can move around together with the clearer image because the camera is closer to the object, so basically you have a better image quality, yeah, and high accuracy, yeah. So when you have better quality of the image, therefore you can, yeah, be more accurate, yeah. On the other hand, the eye to hand configurations, it provides wider view, yeah. You can see more area, and the fixed location of the cameras and object reduce the complexity of the calculation for the robot arm towards the objects, yeah. The need of vision sensor in the grocery robots compared to the industrial robots is because the tolerance or the size of the object for the grip for the robot to grip uh, are, are not that consistent, yeah, and they come in various shape, yeah, compared to the industrial, which is consistent, yeah. So therefore we need the vision assistant, and vision assistant also provide contactless measurements, yeah, so they reduce the collisions of the sensor, the environment, yeah, and then we try to use mono vision here, yeah, instead of multi vision or binoculars, yeah, because first it can reduce the cost of the camera, yeah. uh, it's more reliable because the installation only require one camera and there's no calibration required, yeah. For binoculars and multiple cameras, the alignments of the cameras are very important, yeah, to define the depth informations. However, in the mono visions, yeah, so that information have to be acquired in other ways, yeah. So here, some researchers using the pinhole image principle together with a similar triangle rule, yeah, together with a marker, yeah. Here, they call it landmarks, yeah. So with a standards, yeah, a standard image or standard patterns, that's knowing the sizes of the patterns, yeah. So with this information, basically they can compute that information, yeah. Some researchers also use multiple measurements, which they position the robot arm at one position, take a photo, and position the robot arm into another known position, and then they take another photo. So by comparing the two photos, that information also can be acquired. Yeah? But here we are more favored into the landmark. Yeah? Landmark. So most of the research carried out here are using mobile robots. Yeah? They use landmark. The so-called landmark is basically graphical, yeah, patterns, either QR codes or a specific design pattern, yeah, to provide uh, distance and position information, or so-called location and position information to the mobile robot. So therefore, the marker is basically a station, okay, fixed on the wall, on the ceiling, or on the floor, okay, and it's called landmarks. Yeah? Okay, so in our system, we are planning to use QR markers, yeah, which is we can use it to offset the drawback of molecular system to obtain the date informations, and also easy to obtain. You can just print it out, right, to the barcode, and also it provides a global reference point. Yeah? So using QR codes, first thing, yeah, you provide the final pattern. So each QR are made from standards final patterns where you have the ratios specified, so that you can scan to the QR code. You can know the orientation of the code, yeah, and the size of the code. Yeah? So, and it's very cheap. You can just print it and easily can produce. Yeah. And most of the grocery items packaging also started to have a QR code on it. So we can basically build a database, which relate the QR code, because the QR code gonna provide the type of grocery, what is it, yeah, and from there we can obtain the physical structure of, or the physical shape of the products and put into the database. Yeah. So once the robot scan the QR code, it will know how, or what is the size and how is the shape of the products. Yeah. So then from there you can also know that the position of the QR code. Yeah. So with relate to the actual shape of the products. Yeah. So from there the position and the orientation of approaching the goods can be calculated. Yeah. And the position where to grab the goods also can be obtained. Yeah. So and these methods have been researched by a couple of researchers here. Yeah. So with that, we see that using monocular vision sensor onto an object grasping system, yeah, we can use the basic key steps to define the object's position and grasping. Yeah. And configuration that we adopt here is the eye in hand, because it provides higher positions and beam mobilities. Okay. With the assistance of the QR code replacing the landmark, we can obtain the position and also the information of the product. Okay. With this, we see the visibility, yeah, of such a project to produce a robot arm that can grab items, grocery items, based on the QR code. Therefore, we propose research toward this area. That's all. Thank you for your attention. Thank you.